Okay, here we have a really interesting radio. This is a Traveler portable regenerative radio. It's a little bit rough, but not unrestorable. This is the front of it. It's got the tuning dial and regeneration and a filament and switch for something. I think that turns the filament on and off. This one does not have a speaker in it. I think it does. No, okay, it does not have a speaker. Okay, it has connections here. The battery's apparently set right there. It plugs there. Okay, there are no tubes in it right now. Okay, now something real cute about this one. The antenna is a loop antenna that's in the cover. Okay, and there's a little piece of metal here that's on a little chain so you don't lose it. You slip it into there like that, and this slips in here, and then you take your connection wires and they plug into the front panel. Now, you know, you talk about something that just is asking to get yanked off, lost, whatever. But that's the way they did it back in those old days. Okay, what we're going to do is we're going to see if we can get this thing working. Not much to it. There's very little to it. Okay, first thing we're going to do, we'll get it out of the case and see what it looks like inside. If everything is in good shape, we'll find some tubes for it and then go for it. Okay, to get it out of the case, I can see there are two thumb nuts here that have to come loose. Okay, and that gets it out. A nice little hookup diagram for your batteries, show you how to hook them up. Okay, we'll set the case aside. We'll have to do some work on the case. All right, here is the radio itself. There's not a lot to it. We have one audio transformer. Well, no, two of them. There are two audio transformers. I'd be willing to bet both of them are probably got problems, but we'll see. Tuning condenser and two rheostats. I think one of them is regeneration and the other one is the filament control. Okay, let's do some ohmmeter checks on it and see if we've got any of it good. Okay. You use an analog meter here, and I'm going to first measure these audio transformers. They are just so many times they're burned out. Okay, put them on an R times 1K scale, and good winding, good winding. Okay, that one's good. Now, the other one, the wires go down underneath. All right, one of the windings is right there. Haha, good. The other winding is right there. What do you know? Both audio transformers are good. Okay. Now, we have one condenser here on the bottom. It's got what looks like, I guess it's wax oozing out of it. Okay, I'm going to go to the R times 100K scale and I'm going to measure it. Okay, it's up into megs, so that'll be okay. Up above 50 megs. Okay, we'll leave that one in there. All right, we've got another condenser right here. Okay, that is going to be on these two connections here. Okay, that's reading about 150K. So it's got a lot of leakage. Okay, it's going to be prudent to replace that one. Okay, there's one more condenser that we want to read. Okay, this is our grid leak condenser. Pull the grid leak resistor off. Okay, that reads open. And our grid leak reads at about 700K. There's no value marked on it, so I assume that's it. It looks like an original resistor. Now, we've got another set of coils here that's in this little potted can, and we'll go ahead and measure those and see if they're any good. Well, either they're potted coils or they're capacitors. I don't know what they are. If they're capacitors, they're a very small value. They don't even give the slightest little blip on the ohmmeter. I don't know what's inside this can. Okay, so the first thing that would be to do, just find a set of tubes and we'll just power it up and see what happens. 150K is bad leakage in most cases for capacitors. But on this radio, these capacitors are across the B+. They're bypass capacitors. 150K across the 90 volts is not a serious problem. So there's a good chance that this radio will work the way it sits. Okay, I'm going to go find a set of UX 199s and we'll see if we can get it to work. Okay, I've got 5 tubes, and what we're going to do now, we have to determine which of these wires is which. Alright, I've got a piece of paper I'll write it down on. Now, I'm going to bet the black is going to be, well, I don't know. Let's see, do they read together? They don't. I got the ohmmeter over here. Okay, if I plug a tube in, we will see where the filament is. Let's see, that will go like that. Okay. Okay, this is the switch to turn it on. It's on. Make sure it is going on. Okay. All right. Now, we should be able to read this filament between two of these wires. All right, I'm going to take the black wire and I'm going to see where it goes. Does it go to any of the pins? Okay, I'm going to check the filament pins, see if they're connected together. All right. Okay, here. Something is just not registering here. They should be connected together. Okay. All right, they're connected together on the bottom. Okay, do they go to any of these wires? Yes, they do. Okay, all right, I'm gonna go. Clearly, that goes to one of them. I'm gonna go to this one and measure it. And there it is. The black is the common. This is going to be the filament. Okay, there's a problem here. The tube socket pins are extremely dirty. Okay, so we're going to have to take these open and scrape them. All right, to get the caps off of there, we need a screwdriver. Oh, they're crappy looking. These are all white with corrosion, and that's why they're not contacting. Okay? So, I will take this X-Acto knife. This is one of the easier types of sockets to clean. Sometimes you can't get the tops off like this, and it's almost impossible to get down in there and clean them. You have to take like a piece of a drill bit or something, go down in there and work it back and forth. This one we can do just by scraping. Okay, all the tube socket pins are now clean. Okay, we know now that the red wire is going to be the filament, and this one black wire here is going to be the common, because those two go to the tube sockets on the filament pins. Okay, so let's see, we have a few more here. Okay, so the red and the black are taken care of. We have a green and a yellow and another black. Okay, I'm just going to ohm here and see if I can find it going to a tube pin somewhere. Okay, green goes to the plate on the first audio. That's a B+ wire. Green is B+. Wow. Okay, now we got another one here, a white one. All right. The white one goes to the plate on the, that's going to be the detector tube, I'll bet. If I go from here to the grid, yes, this is the detector. So the white is the detector power. All right, we got one more here. I'm not seeing the B+. Okay, so there has to be another connection here somewhere. You know, unless something's burned out, which it looks like. Okay, we have this little box here. This little box. The plate goes straight to that little box, and it doesn't go anywhere else. Okay, this little box is screwed. Okay, I don't know what it is. I have no idea what that little box is. It is, I suspect, a coil. But it is open circuit totally, so we'll have to fix it. Since this thing is obviously symmetrical, the first thing I'm going to do, oh, here it is. Radio frequency transformer, it tells what it is. Okay, plate grid, B+ and F. Okay, and if we got the ohm meter set up, plate and the grid, we get nothing. Plate and B+, we get nothing. Grid and filament, we get nothing. It is open circuit. Okay, let's see. What do we have to do to get it open? And there it is. wax. Okay, what I will do, I'm going to go ahead and put it in the oven at about 250 degrees and heat the wax up and melt it out. Quite clearly we've got open coils in there. Very, very typical on these old radios to have all kinds of open coils. And this was because the wire, when they made that very fine wire, they did not have the technology to make that wire without stresses in it. A lot of times what they would do, they would extrude it at a certain size, and then to make it smaller, they would stretch it. And that makes it smaller, sure, but it also makes it to where it has stresses in it, and it'll break on you with the slightest temperature change. So that's why these transformers go bad all the time. Now there's another one here. This is going to be another one. Here's another transformer. Let's see if it's good. It reads. Alright, one of them is good. Okay, one of them is good. Okay, so this transformer here is good. It's another RF transformer. Okay. Alright, I'll go heat this one up in the oven, and then we'll pour the wax out of it and see if we can find the trouble. Okay, here's the little RF transformer. And I can see loose wires all over the place. They were just all broken. All broken. Okay. What I wonder, are the coils good? They can't be. There's wires broken all over the place. There's multiple broken places on this one coil. I suspect this is a lost cause. Okay, I'm just going to pull these wires. This wire is just literally rotten. It just breaks. See it? Just the little strands just breaking off of there. It's terrible. Okay. Okay, it's a single layer of wire. Now when we go back and rewind it, we'll use high quality polythermally insulated wire made by Belden, and there's not that wire isn't going to be shattering like this. I mean, this stuff is just pulverizing. Little strands of it just breaking and pulverizing. Okay. That's our spacers. That's our holders. Okay. And these are the two cores. Okay, this is about number 36 wire. Let's see what I've got. Okay. Number 37. I was pretty close. Okay. All right, let's get the coil winder. Okay, just by chance, the hole through the center fits over the shaft on the winding machine, so that's going to be easy. Now, I'm going to take the core, or the coil form, and I'm going to wrap it with double-sided tape, so we have sticky sticky on it. Okay, and that'll make the wire stick in place. Okay. Hanging off of it. Okay. I'm going to put a piece across that gap so it doesn't tend to unwind on me. Wasn't quite long enough, the piece of tape wasn't quite long enough to go all the way around. But this will do it. Okay. Okay, that gives us a sticky surface. Okay, and when we power up the winder, it turns. Okay, now I'm going to put the spool wire over here. Okay. Take the end of this and I'm just going to fasten it here. Okay. I need a piece of tape. Keep it from coming loose. Okay. This thing's got the setup for doing a perfect even layer, but yeah, that's a lot of trouble to set it up, so I'm just going to hand wind it. All right. You know, when you got the right equipment, it's really pretty easy to do this stuff. Okay. Get in there. Here we go. I just kind of hand wind it on there even. It's a little easier to do than it looks. The wire tends to fall evenly. These transformers are not that critical. Alright, here's the little box. Okay, now, you take this thing, okay, we slip these on there like that. Okay, and then we slip that like that. Okay. And then we take these little ends. Wow. Push it against the table. Ah! There it is. Okay. Now, our little transformer is back together. Okay. And that is going to sit down inside there. All right. Now, what I have to do, I'm going to hook these coils to these here, okay? First I have to skin that wire. This is enameled wire, so you can't just wrap it. You've got to skin it. Just very carefully drag the corner of the blade over the wire. Don't press hard or you cut the wire. Alright, that looks good. Now I'm going to go ahead and ohm it. Make sure that it's connected. Okay, go between these two and we've got connection and connection. Okay, now I'm going to use heat glue to hold the thing in place. I'm just going to take heat glue and slop it in there, and that's going to hold it down. I'm going to take this and I'm just going to slop this stuff down in there. Okay. All right. That's the grid. Okay. It goes to there. That's grid. And we just slip that into there. Okay, now let's, this one here, I don't know what is. It is definitely C minus, okay? That one is C minus. All right. No, the green. Okay, green is the high B plus and white is the low. Okay. All right, so what we'll do, put some tubes in it and see if it works. These tubes have got dirty pins on them, so I'm going to just do a little scraping on them. Alright, see that we've got nickel-plated pins. They can be just as bad now. Okay, that one I've already scraped. Oh, this one's so miserable. That one there looks really good. Okay? Okay, that gives us our set of tubes. Okay, I got a horn speaker here, a Radiola horn speaker. We'll try it with that first. It may not drive a speaker, but we'll see. It might. It might do it. Okay, we've got a power supply. Got that hooked up to the various wires. Okay, we'll take the horn speaker and we'll plug it into the adapter here. Okay, now we've got it turned on. Well, okay, when I touch the grid leak, what that does is it feeds 60 cycle from my finger through the audio amps. Okay, I'm going to just do that. I'm going to adjust the C What I wonder is what the tuning range of the radio is. It doesn't seem like it tunes very well. What it was is this connector wasn't making. I suspect this one isn't either. These are dirty. Okay. All right, it's working. The highest frequency this thing will go to, though, looks like it's about 1270. What that means is, let's see, the lowest, that's at the lower end. About 520. So the low end is right, but the high end we can't get up there. Alright, that's how we get an old radio like that going. Okay. Now, for the power supply, we'll read the voltages. Okay, we're running 4 volts on the filament. Okay, we run it down. Okay, so we're going to put 4 volts for the filaments. Okay, the high B plus, we're running at 67. Okay, let's try 90 and see what it does. Okay, it's a little louder at 90, about 15 milliamps. There's not enough difference between 67 and 90 to make it worthwhile. So we'll run the high B plus at 67 and the low B plus at 45. Okay, let's try. That's 22. That's 45. So we can run the detector at 22. Okay, so we'll need 22 volts for the detector. Okay, C minus, 0 volts. We don't need any C minus. So we'll just take C minus and connect it to ground. You really only need C minus when you start getting up into higher B plus voltages. We're not going to run over 67, so we don't need the C minus. Okay, that's it. That's a cute little radio. It had very little wrong with it. The transformer was the main thing that was wrong. The capacitors are good enough to where we don't have to bother with them. Now, something I just discovered looking more closely at the original cardboard they have in the back here, this thing had a speaker in it at one time. Well, that thing's missing. We can see here, this is a clear grill cloth, and the speaker was up in the top here. Okay, what we're going to do is we're going to make a speaker for it. It's got to be a horn speaker, because this thing doesn't have a, back in that day they did not have the standard cone type speaker, so we're going to make us a little horn speaker that will fit in there. Now, we have to have it to where the output of the horn is on the front, and we're going to curl it around to where the driver is here in the back. Okay, we have to have it so the output of the horn is up in the front, and then we'll curl it around, bringing the exponential horn, and we'll, in the back, have the driver. Now, for a driver, I'm going to use a small car speaker. Now, this little bitty thing here, this is a mini speaker that came out of a kind of a boom box that was made to go in a car. So it's very small, it's 8 ohms, so we'll have to have a transformer with it. But that will be the driver that we use with the horn. That'll fit right in there just nicely. Alright, the first thing to do, we'll take a piece of cardboard and we're going to put it up in there, and we're going to trace on there the pattern that we have to have for the horn. Alright, now I'm just going to hold that there. Now the front of the horn will be right down at the top, so I'm going to go, let's see, that is going to go, I'm going to come right straight like that. Okay, it's got to be exponential to do right. Go like that. Okay, that's about right. This has to go a little wider then. Okay, so that's going to be the shape. We're going to go right there. Cut it off right there, and the driver will mount right there. Okay? Now, that we're going to go ahead and make out of plywood. Okay, I'm just going to cut this out. Okay, and that's going to be the shape of the horn. Okay, let me find a piece of plywood. Okay, now here we've made the speaker frame. Okay, all right, and that is going to fit inside the box right like that. The little driver is going to fit right on the end like that. Okay, now we have to fill in the sides. Okay, to do that, we've got veneer. I got lots and lots. I got boxes full of veneer, sheets of veneer. Okay, this is just thin veneer. It'll go right on there like that. Come to here, it'll curl around just like that, no problem at all. Then we'll just take a scissors and we'll trim it off. Okay? Okay, this one here is elm. Oh my goodness, these boxes are samples of veneer that you get from a veneer company. And they got every different kind of veneer you can imagine in there. And just all kinds of different stuff. But there's only one piece of each one, one little piece of each one. So, you know, not really much you can do with it other than what we're doing right here. All right? I'm just going to heat glue that onto there. I'm running out. I'm going to put another stick. And we'll just grind that off of there when we get done. Okay? Heat glue works pretty good. It's quick and it sticks darn good. Okay, here's our finished speaker, little horn speaker. It fits right in the box. See, that'll go right in there like that. We'll have a little transformer here to match the driver, and that's going to make it very close to the original. I have no idea what the original was. They show it just as a box here. But it's pretty small because they have a battery up here alongside of it. So they didn't have much of a horn in there. Well, we don't either. It'll work okay though. Okay, to hold it in, I'm just going to heat glue that thing. I'm just going to heat glue it. Okay, that's it. Like it or not, it's in there. That sucker's in there. Okay, that's going to do just fine. Okay. Okay, now we're going to paint the box. This box is all scuffed up. Not much we can do about that, but we can take it and paint it. I'm going to take lacquer thinner first and just wipe it down. And this will take off any grease or oil that's on the surface. And it's got plenty. It's just lacquer thinner. Take off the top layer of whatever kind of paint this is that's on here. Now the front itself looks very nice. So I'm going to leave the front and the grill cloth and all that original. The radio fits right here. But this looks real nice, so I'm going to leave that original. The outside box, which is all goofed up, we'll go ahead and we'll paint. So what I'm going to do is I'm going to put the cover on it so the inside does not get painted. And we're just going to paint the outside of the whole thing. The painting can either be done by mixing the paint to some custom color or just use something you find at Rust-Oleum. I'm going to use, it's called Kona Brown. Alright, we'll just blast it. Alright, That looks very good. Now that's got to dry for a whole day, so we'll just leave that till tomorrow. Okay, here we see our battery hookup. It has 3 of the big dry cells for lighting up the filaments, and it has 2 huge B batteries for supplying the 67 volts or whatever it is that it has for the plate voltage. Alright, we're going to do it a little differently. Okay, for the filament, they wish they had batteries like this back in the old days. This is a single cell 3 volt lithium cell. It's a lithium polymer battery. This little thin small battery has actually more capacity than 3 of those old dry cells together. It's just amazing at the difference in the capacity. So we use that for the filament. For the B+, we're going to use alkaline batteries. Okay, we got a set of 8 9-volt alkaline batteries. They're wired up in series for a total of 72 volts, 9 volts each. And that's for our B+. Now I don't have these mounted in here because I'm not going to leave them in here. They're just to demonstrate the radio working. Alright, I'll go ahead and hook the batteries up and we'll see if it works. Well, here's our radio, our 1920s portable radio. Finished, being restored. We've got the antenna connected to its jacks. Alright, let's see what happens. We've got the batteries connected up. We turn the switch on, and there's our signal. And that's it. Now we see from this restoration that our biggest problem by far was that transformer that had to be rewound. Okay, and the second problem was the speaker was missing altogether, so we had to make that that speaker to go in there. But that works quite well, and I'm going to disconnect the battery now so that we don't run it down. And you know, you can run it with a battery, or you can make a little power supply that puts out the 3 volts and the 68 volts for the, or 67 volts for the B+. But since this one will be sitting on the display shelf, we're not going to leave the batteries in it. Okay, that's it for restoring a 1920s portable radio.